Hi friends, my name is Maruti and I am the co-founder of Cracku. In this video, we'll be looking at 10 important questions in geometry for CAT. All these 10 questions will be from either easy or medium level. So this is a good video for beginners who have just started preparing for CAT to watch and try to solve the questions. Now geometry is in general a very important topic for CAT. Every year in the quant section, as you know, there will be 34 questions in quant. Now out of these 34 quant questions, there are at least 7 to 8 questions which are asked in geometry. And many of the geometry questions can be answered if you know the theorem or if you know the applications of important concepts. So by solving these kind of questions, it will help you in improving your accuracy as well as speed. Now before we show the answer, we'll first display the question. So all of you, I would recommend first try to solve it on your own. If you're not able to solve it, or if you want to check whether you have solved it correctly or not, then please go ahead and watch the solution for the video. So the 10 questions will be one after the other, and first the first question will be displayed, then there will be its solution, then the second question will be displayed, and so on. In general, if you are preparing for CAT, Cracku is giving a lot of free stuff for students who are preparing for CAT. So the free materials that we are providing, the links to all of them will be given in the description below. In general, we are giving 3 CAT mocks for free. These mocks are very close to in the same pattern as CAT, and they are very similar to what will be actually asked in the examination. So if you want to see how you are preparing, go ahead and attempt these mocks so that you will get a good idea of where you stand. These mocks are attempted by thousands of students all across the country. So the percentile and the rank that you will get will also be fairly accurate. The next thing that we are providing is CAT previous papers. We are providing CAT previous papers both in the PDF format. So if you want to just download the paper and solve some questions once in a while, that is also fine. There are many people who actually want to attempt the CAT previous paper as a mock. So if you would have taken the examination say 2017 or 2018, how much would you have scored? This you can easily figure out by taking the CAT previous papers in the test format on our website. The link for the same again will be given in the description below. Finally, one of the very important things that we are doing, which is extremely helpful to thousands of students, is CAT daily target. So every day we are providing one LRDI set, one reading comprehension set, and 5 questions from the same topic in quant for free to all the students. So all of these questions will have video solutions, and they are attempted by thousands of students every single day. So many students have mailed us saying that CAT daily target is helping them quite a lot. So if you want to get started, if you want to work consistently, do one thing every day. Just go and solve the CAT daily target in the morning every day. We'll release it at 8 AM and it will be free for all the students from 8 AM of this day to 8 AM of the next day. So for the first 24 hours, the CAT daily target will be free for every one of them. And as of today, every day we are getting around 1500 to 2000 students who are taking this CAT daily targets. So again, the link for the same is given in the description below. Go ahead and start solving them. All the best, and I hope you prepare well for CAT. In this question, we are asked to find the number of isosceles triangles that have integral sides and whose perimeter is equal to 24 units. We are asked to not include the equilateral triangle. There will be one equilateral triangle obviously, which has all 3 sides as 8, 8, 8, because then the perimeter will be 24. As we know, equilateral triangle has all the sides equal. Now to solve this question, let us assume that the sides of the triangle in an isosceles triangle, 2 sides are the same. So let them be A, and let the third side be equal to B. So as the perimeter is equal to 24 units, it would mean that 2A plus B is equal to 24. And we need to find the number of integral solutions for this equation. We have to also take into consideration that A is not equal to 8, because then A will be equal to B, and then all of them it will be an equilateral triangle. There is another thing that we will have to take into consideration, that is, in a triangle which has 2 sides equal to A and the third side is B, by the triangular rule, the sum of 2 sides is greater than the third side. So A plus A is greater than B. This has to be true, that is 2A is greater than B. Similarly, the other sides, that is sum of this side and this side, will always be greater than the third side, because A plus B is always greater than A. So the only inequality that we have to keep in mind is that 2A is greater than B. So let us try to solve this. Because 2a plus b is equal to 24, and this has integral solutions. B is even, because if b is odd, 2a will be 24 minus an odd number, which will be an odd number. So a will be not a natural number. So for example, if you put b is equal to 1, we would get 2a is equal to 23, or a is equal to 11.5. This is not an integer and this is not valid. So b has to be even. So let us put first b is equal to 2. In that case, a is equal to 11. This is one solution. The second case is b is equal to 4, then a is equal to 10. This is the second solution. The third solution is b is equal to 6 and a is equal to 9. This is the third solution. We can't put b is equal to 8 as discussed earlier, because then a will also equal 8 and it will become an equilateral triangle. So b is not equal to 8. We'll go to the next one, which is b is equal to 10. In this case, a is equal to 7. This is the fourth equation. If we put b is equal to 12, we'll get a is equal to 6. But this is not a solution, because then 2a is not greater than b. Therefore, this equation has only 4 solutions, which are given above. In this question, it is given that there is a cube which is painted, which is cut into 1000 smaller cubes of equal size. We are required to find out the small cubes which have exactly one face painted. So let us assume that the initial dimensions of the cube are 10 into 10 into 10, and now each of the smaller cube will have a dimension of 1 into 1 into 1. Now if you look at it, some of the sides will have all 3 sides painted, some of the sides will have only 2 sides painted, some of the sides will have 1 side painted, and some of the cubes will have no sides painted. We are required to find out what is the value of the number of cubes with only 1 side painted. So if you look at a cube, it will look something like this. Now this is a cube which is cut into different pieces. Now if you look at the corners of the cube, there are 8 corners. Each of the cubes which are at the corners will have all the 3 sides painted. So the number of cubes with all 3 sides painted will be 8. Similarly, if you are looking at, if say you are looking at one of the intersections, say this is one of the sides, say this is one of the intersections, this is one of the sides of the cube. So this is 1, 2, 3, 4, 5, 6, 7, this will be 8, 9 and 10. So this is a 10 cross 10 side, though this is one of the sides. Now you look at it, then in each of them, the sides which are interior, that is all of these cubes, will have exactly 1 side painted. This will be in each of this side. This is a 8 cross 8 square, and there are 6 such sides, 1, 2, 3, 4, 5, 6. So the number of cubes with exactly 1 side painted will be 8 into 8. This is basically all the sides in the interior square into the number of sides, which is 6. If you calculate this, you are going to get 384. Similarly, all the cubes which are inside, in the initial cube is a 10 cross 10 cross 10 cube. All the smaller cubes which are inside the 8 cross 8 cross 8 cubes will have no side painted. This will come to 512. So the 0 will be 512. And the number of cubes which have 2 sides painted, if you just look at one cross section, it will be all of these cubes. So this is again 8 cubes here, 8 cubes here, 8 cubes here, and 8 cubes here. So if you look at it on the cube, there will be 8 here, there will be 8 cubes here, there will be 8 cubes here, there will be 8 cubes here. Similarly, on each of the vertical vertices also there will be 8. The one at the back, this will also have 8, this will also have 8. Similarly, in the 4 bottommost corners, you will again have another 8. So in each of these, the cubes which are in the middle, which are in the corner but in the middle and not at the 8 vertices, they will have 2 of their sides painted. So the number you will get over there is 8 into 12. So for a 10 cross 10 cross 10 matrix, that is 10 cross 10 cross 10 cube, which has 1000 smaller cubes, The number of cubes which have 0 sides painted will be 512. This is basically 8 into 8 into 8. The number of cubes which have exactly one side painted will be 384. This is basically all the cubes on each of the faces, where each of the faces will have 64 cubes in the middle. The number of cubes which have two sides painted will be on each of the faces, the ones at the top or at the side or at the bottom or to the other side. This will be 96. And the number of cubes which have all the three sides painted will be at the exact vertices of the cube, where there are 8 such vertices. So it will be 8. If you actually count the total, you will again get this to be 1000. Of this, we are looking for the number of cubes which have exactly one face painted. So the answer in that case is 384. In this question, we are given a point A, and we are given two tangents from A to a circle, that is AB and AC, and we are told that the radius of the circle is 5. We are told that the length of each of the tangent is 5 root 3. We are required to find out the area of the shaded region. So let us just draw the diagram in a bigger manner. So say this is the circle and this is a point A from which we have two tangents. They are not straight lines, but assume that they are straight lines. So say this is A, this is B, and this is C. This is the point O. Now the point O will be perpendicular to C and B because they are tangents. So any tangent, when you draw a line from the center to the point where the tangent meets, in this case B, it will be a right angle. Now let us connect O to A, and this is the area of the half the area of the shaded region. So what we plan to do is, we will first find out the area of this shaded region. We will multiply it by 2 to get the total area of all the shaded region. Now to go ahead with even this, what we will do is, we will first find out the area of the triangle OAB. From that, subtract the area of the circle, that is part of the circle OA, say if this is D, OABD, and then get the area of half of this shaded region and multiply it by 2 to get the whole shaded region. Now to proceed further, we will have to first calculate the angle BOA. We know that OB is 5 and the length of the tangent AB is 5 root 3. Now if you assume that the angle BOA is theta, tan theta is equal to 5 root 3, which is the side opposite to it, by 5, which is the side adjacent to it. So this is 5 root 3 by 5, which is equal to root 3. Therefore theta is equal to 60 degrees. This is the first step in solving this. Then we can calculate the area of this chord, the arc that is subtended, which is OBA. So if you are calculating the area, this area of OBD, this is equal to 1/6 the area of the entire triangle. Why is it 1/6? Because we know that theta is 60 degrees. So the area of this circle, area of the part that is shaded is 60 by 360 into pi r square. Pi r is 5, so r square is 25. So this will come to 25 pi by 6. Now what is the area of the triangle BOA? Area of triangle BOA is equal to half into base into height. Base is 5 root 3 into height is 5. Because this is a right angle triangle, we just have to multiply these two. This comes to 25 root 3 by 2. Therefore, the area of this shaded region is the difference between these two. That is the difference between the area of this triangle minus the difference of this chord. So if you are doing that, you will get this as 25 root 3 by 2 minus 25 pi by 6. But remember that this is only half the shaded region. To get the total shaded region, we will have to multiply it by 2 because of symmetry. So if you are multiplying it by 2, this will be the final answer. If you simplify this by taking 25 common, this will be 25 into root 3 minus pi by 3. This is the answer. To calculate it, once you get the angle of BOA correct, which is equal to 60 degrees, everything else will fall into place quite easily. In this question, we are given that there is a walking track AB, which is the diameter of a circular park of radius 10 meters. So let us assume that this is the circular park and this is the diameter AB. AB is the walking track.
Now a pole of height 6 meters is standing on the circumference of the circular track and it subtends an equal angle at A and B. That is, it is equidistant from both A and B. So it will be at the midpoint of the arc AB. Now let us assume that the base of the pole is say R. Okay, there is another point R. So let us assume that the base of the pole is say P. A point R lies on the line AB and the pole subtends 30 degrees at R. So there is a point R on AB, and when you connect the base of the pole to R, and if you draw another line from R to the top of the pole, remember that this is in 3-dimensional figure. So this angle, that is the angle subtended by the top of the pole at R, is 30 degrees. We also know that the height of the pole is 6 meters. So from this we can get the distance of PR on the ground. So PR 6 by PR is equal to tan 30 degrees. Therefore PR is equal to 6 root 3. Now PR is on the ground. The pole is up in the air. So 30 degrees is subtended at the top of the pole. So tan 30 degrees will be the height of the pole by the distance on the ground, because that is opposite side by adjacent side. So we get that PR, that is the length from R to the base of the pole, is 6 root 3. Now once we know that, we are required to find out the distance of point R from the center. Let us assume that this is the center O. Now if you connect P and O, because P is equidistant from both A and B, it will be a perpendicular at the center. Now this is a right angle triangle. You know one of the side, this is the radius of the circle, which is 10 meters. And you know the length of the hypotenuse is equal to 6 root 3. You are required to find out the length of the third side, which is OR. Now OR square plus 10 square by Pythagoras theorem is equal to 6 root 3 whole square, which is 6 square into 3. 6 square is 36 into 3 is 108. Therefore OR square is equal to 108 minus 100, which is equal to 8, or OR is equal to square root of 8, which is 2 root 2 meters. Now if you are able to visualize this simple diagram in three-dimensional space and figure out that the length of PR is 6 root 3, the question is nearly solved.
The secret to crack CAT is taking a lot of marks. We at Cracku give all the previous year's CAT, XAT and IFT papers in the actual exam format. Also, if you just Google Cracku free CAT mark, you can find 3 free CAT marks in the latest exam pattern. You can take them and get detailed analysis.
In this question, it has been given that there is a right angle triangle. The inradius of the right angle triangle is 3 centimeters and its circumradius is 8.5 centimeters. We are asked to find the area of the right angle triangle. Let us assume that the 3 sides are A, B and C. So C is the hypotenuse. Now by using the formula, inradius of a right angle triangle is equal to A plus B minus C by 2, and the circumradius is equal to half the length of the hypotenuse. Therefore, we can just input the values that are given, that is A plus B minus C by 2 is equal to 3 and C by 2 is equal to 8.5. Therefore, C is equal to 17. This is the length of the hypotenuse, and A plus B by 2 is equal to 11.5, or A plus B is equal to 23. Remember what we have to find out. We have to find out the area of the right angle triangle, and the area of the right angle triangle is equal to half into base into height. So we need to find out the value of half into AB. Now because this is a right angle triangle, C is equal to square root of A square plus B square, and we already know the value of A plus B. So if we square both sides, we get A square plus B square plus 2AB is equal to 23 square, which is equal to 529. But we know that A square plus B square is equal to 17 square. So we can replace this with 289, which is equal to 17 square, plus 2AB is equal to 529, or AB is equal to 120. Now to find out the area of the right angle triangle, we have already discussed that it is equal to half AB.
So this becomes 60. This is equal to half of AB. So the answer is 60.
In this question we are told that ABCDEF is a regular hexagon with side length of 1 centimeter. So let us assume that this is the regular hexagon A, B, C, D, E and F. We are required to find out the area in square centimeters of a square where AC is one side. So we are assuming that AC is one side of a square and we are required to find out the area of the square. We know that area of a square is equal to L square, where L is one of the sides. So if you are able to find out the length of AC, we will easily calculate the area of such a square. We know that AB is equal to 1 and AC is equal to 1. We know that angle ABC is 120 degrees. Because this is the interior angle of a regular hexagon, the angle will be 120 degrees. So we need to calculate the length of AC. We'll just draw ABC for ease of understanding this method. Remember that you can use the cosine rule to calculate the length of cosine law to calculate the length of AC, but we'll try to not use it because there's a much easier way to calculate it. This is ABC. We know that AB is 1. We know that BC is 1. We'll draw a perpendicular from B to C. Let us assume that this is D. Because this is an isosceles triangle, this will also be the midpoint of AC, and this is 60 degrees and this is 60 degrees. This is 90 degrees. So BAD will be 30 degrees. So you can easily figure out that AD is equal to the length of hypotenuse AB into cos 30 degrees. We already know that AB is equal to 1. So AD will be root 3 by 2. That is AD is root 3 by 2. Therefore CD will also be root 3 by 2. And the length of AC will be root 3 by 2 plus root 3 by 2, which is equal to root 3. Therefore, the area of the square is L square, so it will equal 3. A man has three metals, iron, aluminium and copper. So the volume of iron is 405 centimeter cube, volume of aluminium is 783 and volume of copper with him is 351. Using these metals, he is making small cylinders. The radius of each of the small cylinders is 3 centimeters. We don't know the height. So we have to ensure that the volume of each of the small cylinders have the same volume. So let us assume that the volume of the small cylinders is V. So as the total metal is 405, for example in iron, the number of small cylinders that he'll make, which are of iron, is 405 by V. Similarly, the number of aluminium that he'll make is 783 by V, and the number of copper that he'll make is 351 by V. These are the different cylinders of different metals that he'll make. Now we have to ensure that the total number of such cylinders is kept at a minimum. That is, we want the sum of these three numbers, that is the number of cylinders of each metal, to be at the minimum. And then we are required to find out the total surface area of each of these cylinders. So what we'll do first is we'll figure out at what value of V will the total number of cylinders be minimum. Use that value of V. From that value of V, we'll get the volume of the cylinders. We already know the radius. So for each of the small cylinder, we'll calculate the height. Then we'll calculate the total surface area of all the cylinders. But first thing, if you want to minimize the sum of 405 by V plus 783 by V plus 351 by V, we have to keep V as high as possible. But we should also ensure that each of these three numbers are natural numbers, because they represent the number of cylinders of each metal. So they can't be fractions. So V has to divide 405, V has to divide 783 and V has to divide 351. That is, V should be a factor of all of these three numbers and V should be as high as possible. This implies that V should be the HCF, that is the highest common factor of 405, 783 and 351. So now if you are given three numbers and if you have to find the highest common factor of these three numbers, there is one small trick which you can use. That is, the HCF of three numbers A, B and C will be the HCF of A minus B, B and C. You can choose any two numbers A and B. If you subtract their, if you find their difference, the HCF should even be a factor of the difference. So in this case, to quickly find out the HCF of these three numbers, we will subtract 351 from 405, because these are the two numbers which are closest to each other. We can find one number to be small, and from then we can find out the HCF easily. So in this case, the HCF will equal 405 minus 351 is 54, 783 and 351. Now if you look at 54, you can figure out that it is a multiple of 9. So we will calculate, it's a multiple of 9 and it's a multiple of 27 and 2. Clearly the other two numbers are odd numbers, 783 and 351. So we will check if 27 divides either of these two numbers. 783, for example, is 810 minus 27. 810 is 27 into 30. So 783 can be represented as 27 into 29. Similarly, 351, if you calculate, can be represented as 27 into 13. So clearly 27 is a multiple of the other two numbers, and we know that 54 is equal to 27 into 2. So the HCF of these three numbers is equal to 27. So the volume V is 27. So the volume of each of the small cylinders is equal to 27. And the number of such cylinders will be 405 by V. 405 by 27 is equal to 405 is equal to 27 into 15. So you will have 15 iron small cylinders. Of aluminium you will have 29 because 783 by 27 is equal to 29, and for copper you will have 351 by V, which is equal to 351 by is equal to 13. So the total number of small cylinders that you will have is 15 plus 29 plus 13. This will equal 57. Now let us calculate the height of the small cylinders. We need the height to calculate the total surface area. So if the height is h, the volume of the small cylinder will be pi into r square into h. This is equal to 27. We know that r is equal to 3. So pi into 9 into h is equal to 27, or h is equal to 3 by pi. So each of the small cylinder, the height is 3 by pi, the radius is 3 centimeters, and the total number of such small cylinders is 57. We just need to calculate the total surface area. Now for any given cylinder, the total surface area is equal to 2 pi r into r plus h. In this case, for each of the small cylinder, the total surface area will be equal to 2 pi into r is 3 into 3 plus 3 by pi. Now you can cancel pi, so this will become 6 pi. You can take 3 also outside, so it will be 18 into 1 plus pi. This is the total surface area of each of the small cylinders, but we have 57 such small cylinders. Therefore, for the entire all these cylinders, the total surface area will be 57 into 18 into 1 plus pi. If you calculate it, you will find out that this is equal to 1026 into 1 plus pi. That is the answer. So there are two steps in this. First, you have to calculate what is the volume of each of the small cylinder. The volume has to be a factor of each of the three numbers that are given, that is 405, 783 and 351. And it should also be as high as possible, because we want to keep the number of cylinders to be at its minimum. Once you figure out that the volume has to be the highest common factor of these three numbers, we then calculate what is the highest common factor. We figure out that it is 27. Using the fact that the volume is 27, we calculate the height of the small cylinder, that is equal to 3 by pi. Then we calculate the total surface area of each of the small cylinders, and then we calculate the total surface area of all the 57 small cylinders. In this question, we are given that ABC is a right angle triangle with B as the hypotenuse. So let this be ABC. This is BC is the hypotenuse, so this is BC and A is the right angle. The lengths of AB and AC are 15 and 20 kilometers. So AB is 15 kilometers, AC is 20 kilometers. Therefore, BC has to be 25 kilometers. This is using simple Pythagoras theorem, that is 15 square plus 20 square. This will equal 25. The minimum possible time in minutes required to reach the hypotenuse from A at the speed of 30 kilometers per hour is. So whenever you are required to find out the minimum possible time, you have to first figure out what is the distance from this point A to the line BC. If you need the distance, you want to draw a perpendicular from A to BC, and the length of the perpendicular will be the shortest distance between a point and a line. So let us assume that it meets the hypotenuse BC at D. So what we are required to calculate is the length of AD. This is the shortest distance from A to BC. Now calculating AD is not very difficult. Let us assume that the angle at B is theta. Now in triangle ABC, tan theta is opposite side, that is 20, by the adjacent side, that is 15. So this is equal to 4 by 3. Similarly, as we have calculated that the hypotenuse BC is equal to 25 kilometers, cos theta is equal to adjacent side, that is 15, by hypotenuse, that is 25. This is equal to 3 by 5. Now in triangle ABD, we are required to find out the length of AD. So AD by AB, AD over here by AB is equal to sin theta, because in this case AD is the opposite side of angle theta, and using cos theta as 3 by 5, we can calculate that sin theta will equal 4 by 5, because we know that sin square theta plus cos square theta is equal to 1. So as you know that cos square theta is 3 by 5, you know that sin square theta will be 4 by 5. So as AD by AC, AD by AB is sin theta, we know that AD is equal to AB into sin theta. AB is 15 into 4 by 5, this is equal to 12 kilometers. There are a number of ways in which you can calculate the length of AD. You can either use trigonometry as we have used now, or you can use the fact that triangle ADB is similar to the bigger triangle ABC, because all the angles will be the same. For ADB, the angles are theta, 90 and 90 minus theta. Similarly, for triangle ABC also, the angles are theta, 90 and 90 minus theta. As they are similar triangles, the lengths of the sides are in ratio of are in proportion. The lengths of the sides which are opposite the same angles. So for example, in ADB, the angle which is opposite theta is AD, and in ABC, the side which is opposite theta is 20. So AD by 20 will equal, in ADB the hypotenuse is 15, and in ABC the hypotenuse is 25. So if you use this also, you can calculate the length of AD. So again AD will be equal to 15 into 4 by 5. This is equal to 12 kilometers. Once you have calculated the length of AD, finding the time required to reach the hypotenuse is quite simple. You are given the distance, you are given the speed as 30 kilometers per hour. So the required time will be 12 by 30 hours. So if you want it in minutes, it will be 12 by 30 into 60. So that is equal to 24 minutes. So the answer in this case is 24. In this question, we are given 4 circles. They are of equal radius. The radius is 2 centimeters. 2 pairs of circles intersect each other, and all the other circles touch each other, as shown in the diagram. Now we are also given that angle PAQ, which is the angle of the chord, is 60 degrees, and the given figure is symmetrical, and we are asked to find out the area that is bounded by the circles that doesn't lie in any of the circles. So the area that we are required to find out is this area. So in the first step that we have to do for finding this area is, our strategy is to first find out the area of the rectangle ABCD. Once we find out the area of the rectangle, we will find out, in fact we can divide this into 2 parts because this is symmetrical. We will try to find out the area of the top rectangle, and from that we will subtract the area of which is contained by the 2 chords, that is this chord and this chord. Now whatever area is left is the area of the top half of the figure. We will multiply it by 2 to get the actual answer. So to start off with, we will have to find the area, length of AD. It is given that
angle PAQ, this is equal to 60 degrees. Therefore, this is an equilateral triangle, and so PQ is equal to the radius, that is 2 centimeters. Therefore, the length of AD will be, if this is O, the length of AD will be twice AO, and we know the value of AO will be equal to, because this is a right angle triangle, the length of AO will be square root of the hypotenuse is AP, which is 2 square, minus OP. We know that PQ is 2, so OP will be half of it, which is 1. So this is equal to root 3. Therefore, AD is equal to 2 root 3 centimeters. This is the first step where we find out the length of the side AD. Now, once we do that, let us consider only this rectangle. Now, the required and we will try to find out the area which is contained over here. Once we find out this area, we will multiply it by 2 to get the required answer. So, to find out this area, let me clear the figure so that it is easy to understand. Now, if you are considering only the upper rectangle, that is this, in this rectangle, the side AD is 2 root 3 and the other side is 2 centimeters, which is equal to the radius of the circle. Suppose this is X and Y. So the area of the rectangle ADXY is equal to 2 root 3 into 2, which is equal to 4 root 3. Now we need to subtract the area that is contained by these two chords. To do that, first let us try to find out the area that is common to these two chords. Then we can find out the area of these two chords. The area of these two chords is quite simple because this is 90 degrees. So this will be 1/4 of the area of that circle. This also will be 1/4 of the area of the circle. And then if we can find the area of the common chord, we can find out the total area that is inscribed by these two chords. So if you, to find out the area that is common to this, to find out this area, for example, we notice that by symmetry, the area that is common over here will be actually the difference in the area when you draw the equilateral triangle and subtract the area of the, when you draw the area of the sector and then subtract the area of the equilateral triangle. So the area of the chord over here will equal, because the angle subtended at the center is 60 degrees, the area of the sector will be 1/6 of the total area of the circle, which is 1/6 into pi into r square, which is 4. This is 2 pi by 3. And the area of the equilateral triangle will equal root 3 by 4 into a square, which is equal to root 3. Therefore, the area of the chord that is left equals the difference between these two, that is 2 pi by 3 minus root 3. We argue that the area of this chord is half of the total area, which is also equal to the bottom half. So in this rectangle that we are considering from the start, we know the common area, that is this area. This common area A is equal to 2 pi by 3 minus root 3. We know the areas of the bigger chords. This will be 1/4 of the area of the circle, and that equals pi by 4 into r square. This is equal to, because r is 2, this equals pi. Similarly, the area of this chord is also equal to pi, and the common area we know is equal to 2 pi by 3 minus root 3. Therefore, the area of this chord will equal pi plus pi minus the area of the overlap, which equals 2 pi by 3 minus root 3. This equals 4 pi by 3 plus root 3. This is the area common to it. Now if you want to find the area of the region that is bounded, you just have to subtract this area from the area of the rectangle. Now we know that the area of the rectangle is 4 root 3. We have just calculated it above. Let me try to make some space so that we can finish the rest of the explanation. Now the area of the rectangle is 4 root 3. So the required area of this region that is bounded equals 4 root 3 minus 4 pi by 3 plus root 3. This equals 3 root 3 minus 4 pi by 3. But we have discussed before that this is only half of it. If you are looking to find out the area of the bottom boundary also, you have to just multiply it by 2 for symmetry. So the required answer will be 2 into this, which is equal to 6 root 3 minus 8 pi by 3. To reiterate, to just going through what exactly we have done, we have first found out the area of this rectangle. Now once we found out the area of this rectangle, we want to just subtract it by the area that we shouldn't consider. And the area that we shouldn't consider is basically the area of this chord, which is 1/4 of the area of the circle, plus the area of a similar chord, that is this one, minus the area of the overlapping chord. So we first found out the area of the overlapping chord. Then we found out the area of the two bigger chords to find out the area that should be subtracted from the area of the rectangle. And once we found out the area of this figure in the bottom, we just multiplied it by 2 to get the required answer, which in this case equals 6 root 3 minus 8 pi by 3. In this question it is given that there is a circle of radius 11 centimeters of which CD is a diameter. So suppose there is a circle, CD is the diameter, the length of the radius is 11 centimeters, so CD, which is the diameter, is equal to 22 centimeters. There is a chord AB of length 20.5 centimeters. AB and CD intersect at point E inside the circle. So let us assume that this is AB, and AB, the length of AB, it is given, is equal to 20.5 centimeters. CE has a length of 7 centimeters, so this is 7. Then the difference of the lengths of BE, this is E, and AE in centimeters. So we are required to find out BE minus AE. This is the difference. So before we get into it, there is one theorem, important theorem in geometry. It is quite straightforward, which is called the intersecting chords theorem. We'll use that theorem in this problem. We can solve it without using it also, but using it the solution becomes very straightforward. So suppose there is a circle and suppose it has two chords. Now suppose the chords are AB and CD and suppose they intersect at S. This can be any two chords in the circle. Then AS into BS is equal to CS into DS. What we are saying is, when we multiply the respective lengths of each of the small parts from the point of intersection, the product will remain the same. So AS, which is this point, this length, into BS, which is this length, will equal CS, which is this length, into DS, which is this length. You can prove it using similarity of two triangles, because many of the angles are equal when you complete the triangles. But there is no need of proof, just remember this theorem, it is an important theorem. We'll apply the same theorem in this problem, because as you can see, AB is a chord and CD, even though it's the diameter, is also another special chord. So once we know that CE is equal to 7 centimeters, we know that DE is equal to 15 centimeters. We know the length of DE because we know the length of CD, it is equal to 22 centimeters, so DE is equal to 15. Let us assume that the length of AE is equal to X, so the length of BA will be equal to 20.5 minus X, because we know the length of AB. Now using the theorem that we just described, the intersecting chords theorem, it would mean that 20.5 minus x into x is equal to 7 into 15. This is a quadratic equation in x. You can simplify it by expanding the bracket. So it will be x square minus 20.5x plus 105 is equal to 0. 20.5 is 10 plus 10.5. You can factorize this easily as x minus 10 into x minus 10.5 is equal to 0. So it has two solutions. Solution 1 is that x is equal to 10 and solution 2 is equal to x is equal to 10.5. Therefore, the length of AE is either 10 centimeters or 10.5 centimeters. In this case, the length of B is equal to 20.5 minus x, which is equal to 10.5. And in this case, the length of B is again equal to 20.5 minus x, so B is equal to 10. In both the cases, the difference between the two chords, the two line segments B and AE, will be 10.5 minus 10, which is equal to 0.5 centimeters. So the answer in this case is 0.5 centimeters. This is a good use of the theorem that we discovered, intersecting chords theorem. Just read it so that you will understand this better.